Hello, my favorite students. How are you guys? I hope doing well. I hope you didn't answer that question to the video because I can't really help you. But I look forward to seeing you guys in class. So guys, today we're going to talk about lesson 14. It's fractions. I love fractions because you're going to use them from now until forever. You may have heard me even say that in class, to be honest. What you really need to know about fractions is this. Fractions. Go ahead and write this down. The biggest thing is part over whole. That's all you really need to know about fractions. Part over whole. So we take the whole pie, right? Something like this. And we say how many, the whole pie is 4, right? 4. And I have shaded in one of them. The part that I have shaded in has been 1. Guys, just as a friendly reminder, this is called your numerator. And this, because it's downstairs, is called your denominator. When we're adding and subtracting fractions, we need a common denominator. You may hear that, and that's that bottom bit, okay? Expanding and reducing fractions. Guys, you will use a lot of fractions in algebra, and you will always be expected to reduce your fraction to the lowest form. There are many ways of doing this. I'm gonna show you a couple different ways so that you've got the right idea. First things first, though, we're gonna talk about expanding one, okay? If you have 3, 4, and I want you to expand to get 24 on the denominator. Yeah, we can do equals. I want you to expand this to get 24 on the denominator. Guys, we need to multiply 4 times 6 in order to get 24, right? What we do on the bottom, we have to do to the top. And if I do that to the top, 6 times 3, that gives me 18. I have just expanded out this fraction. Let's see about, okay, one other thing is, and make sure you're taking notes as you're watching these videos, you're writing these guys down. One other thing, you can turn anything into a fraction by putting it over 1. So 5 over 1. If I wanted you to do this and I wanted you to have a denominator over 20, so take the number 5 and turn it into a fraction with a denominator of over 20. I would need to multiply that 1 times 20 to get 20. And if I did it on the bottom, I would have to do it on the top. 20 times, or 5 times 20 would give me 100. 100. So that is so 5 written as a fraction with a denominator of 20 is going to be 100 over 20. The big thing is, write this down. You can turn anything into a fraction by putting it over 1. Write that down, star it, flag it, do something. Let's take 3/5, and I want you to write this with a denominator of 20. We would take 5 and we'd multiply it by 4 to get 20. What we do on the bottom, got to do on the top. We get 12. 12 over 20. Beautiful. All right, let's talk about reducing fractions. This one's not in the book, but I love this. You can divide top and bottom by 10. What you're really doing is just lobbing off those last zeros. Guys, this only works for zeros. Don't let this happen for 5, 2, 7. Doesn't work that way. But you can just lob off zeros, and this is 3/4. Okay, I love 10s for that reason. But let's say you have 30 over 45. 30 over 45. There are multiple ways of reducing fractions, and I'll show you a couple just so you think you can get the best feel for it, okay? What we could do first is find the greatest common factor between these two numbers. I've got 1 times 30, 2 times 15, 3 times 10, 5 times 6, right? 45, I got 1 times 45, 3 times, I always forget, 3, I get 1, 3, 15, right? Because 3, 1, 5, 5 times, yeah, 15. 3 times 15, not 4, but I can do 5 times 9, not 6, not 7, not 8, right? But then 9, and 9's already on the board. So our greatest common factor with these guys is 5. So I could divide the top by 5 and divide the bottom by 5, and I would get 6 over, oh, I made a mistake. Because if we did 9, right? Where did I make my mistake? Oh, 6, let me think about this. 3 times 5. Oh, you guys, I made a mistake. Look at, our greatest common factor isn't 15, guys, or isn't 5, it's 15. 15, but see, if you make that mistake, you can always just keep dividing on, not a problem. I'm like, what did I do? Divide this by 15 and divide this by 15, I get 2 over 3. 2 over 3, okay? So that's dividing by the greatest common factor. Now, let's say I didn't, and I made that mistake and I did the 5, right? You saw what happened. I divided by 5, I divided by 5, and I got 6 over 9. And I looked at that and I'm like, well, I know that 3 goes into both those. So then you have to divide by 3, I end up with 2 over 3. It was a two-stepper, and that's totally fine. If you just want to keep cutting numbers in half until you get to where you need to be, or dividing by 3 or dividing by 5, that's fine. Guys, when we're reducing fractions, generally like 90% of the time, you can just divide by 2, 3, or 5 until you get all the way into the bottom, okay? And that's what I did. And of course, 5 times 3 is 15, so that's how I could have done it straight away at the beginning. Okay, another way of doing this is, that was finding the greatest common factor. And that way that I just showed you where I divided by 5 and then divided by 3, that's my favorite. I usually do like divide by 2, divide by 2, divide by 2 until it gets to the end. I don't necessarily find the greatest common factor all the time. However, knowing your multiplication tables, that's a lot easier for finding the greatest common factor. Another way of doing this is, we talked about prime numbers. 30 can be broken down into 3 and 10. 3 is prime, 2 and 5, right? So really, we could rewrite 30 as 2 times 3, which is 6, times 5, which is 30. And then on the bottom, we could do the same thing. 45, which it can be broken down into 5 and 9. 5 is prime, 9 is 3 and 3, okay? So there's 2 3s. I'm not gonna write 3 squared, I'm gonna write 3 times 5. So 45 is written as 3 times 3 times 5. Guys, if it's on the top and the bottom, you can lob it off just like that. Just like this, and I'm left with 2 over 3, okay? So that's another method for doing these. All right, so for example 14, reduce 16 over 32 by using the greatest common factor. So this time it asks us to do that specifically. We get 1 times 16, I'm gonna do 16 right here. 1 times 16, 2 times 8, 3 times, nope, not 3. 4 times 4, right? And then I'm done. So 32, I get 1 times 32. 2 times half of 30 is 15. Half of 2 is 1. 15 and 1 is 16. Not 3, right? But if we did 4 times 8, we could do that one. Not 5, but we could do not 6, not 7, and 8's already on the board. All right, looking at all of these, our greatest common factor is 16, right? So if I divide the top, and if I divide the bottom, I can't even talk today, by 16, I get 1/2. Guys, it's also a good idea when you're looking at your fractions to know half. Like if you have 8 divided by 16, you know half of 16 is 8, so this is automatically 1/2. If you know 16 is half of 32, you can just cut right to the chase. But that's how you're gonna use your greatest common factor. All right, so, getting a little excited there. Page 53, there are practice problems about halfway down the page. Let's go ahead and pause the video at this time and then go ahead and do those practice problems. Come on back when you're ready. All right, so for A, we have 3. Write each as a denominator of 18. Guys, we can turn anything into a fraction by putting it over 1. Oop, that was not in the middle, 1. And I want it to be over 18. So I need to multiply this by 18 and multiply this by 18 in order to get that 18 over there. 3 times 18 gives us 54. Good, so it would be 54 over 18 would be your answer. For B, we have 1 over 6, and I want that to be with a denominator of 18. I need to multiply that 6 by 3, and what I do on the bottom, I have to do on the top, so I would get 3 over 18. All right, for C, I have 4 over 9 equals something over 18. I would take that 9 and I'd need to multiply that by 2 to get 18. What I do on the bottom, I need to do on the top. So 4 times 2 gives me 8. All right, for D through F, we are going to reduce those fractions to the lowest form. For D, we have, and I don't care how you do this, whatever method you want to do. I'm going to show you what I do. 18 over 24. Remember what I said about fractions? You just need to ask yourself, is it divisible by 2, 3, or 5? Friendly reminder, even numbers are divisible by 2. If you add all your digits up and it's something that 3 can go into, then 3 is going to go into that number. And then 5 is if it ends in a 0 or a 5. If you guys have questions about this, go back and watch lesson 10, I believe it is, divisibility. I look at these, I see they're even. I'm gonna divide them by 2. And remember, dividing by 2 is just cutting things in half. So if I cut this in half, I get 9 over 12. Okay, well, I can't cut it in half again, but I do know I can divide by 3, and I end up with 3 over 4. So I don't necessarily care about the greatest common factor or anything like that. Just reduce your fractions however you want to. So E is 36 over 72. 36 over 72. All right, again, those are both even. I'm gonna cut them in half. Half of 30 is 15. Half of 6 is 3. 15 and 3 is 18. Half of 70 is 35. Half of 2 is 1. So this is gonna be 36, okay? Equals, I can cut those in half again. 9 over, and half of 36 we determine is 18. Guys, at this point I'm looking at it and I'm like, oh yeah, 9 is half of 18. So this is all gonna reduce down to 1/2. Now, if you looked at that and you didn't catch on to that quite yet, we know we can't cut these in half because that's not even, but you could divide. So that's when you ask yourself, okay, you can't do 2, so let's try 3. Divide by 3, divide by 3. I end up with 3 over 6. Again, I can divide by 3. Divide by 3, divide by 3, 1 over 2, 1/2. So guys, I don't care if you have to do this long train of reducing your fractions. I really don't care. Use the greatest common factor, use whatever you want, just make sure you're reducing it all the way. That's the priority here. I don't care about the method, just make sure you're reducing your fractions. 15 divided by 25. Again, 2, 3, or 5. 2, 3, or 5. 5, because these both end in 5. So let's divide by 5, divide by 5. I get 3 over 5. Can't reduce that any further, so I'm good to go. All right, if you guys have any questions, let me know. Otherwise, happy fraction reducing, and I better not see any more fractions that are that need reducing. All right, thanks guys.